Alright, everybody. Okay, so this lesson is very important, and I need to take you through the steps to find empirical formula based on the masses. Okay, so we are now at page 653 of the binder, and I hope that you will take a look and follow carefully. So whenever we want to find empirical formula and we are given masses like this, I am given 53.64 of phosphorus and 56.36 of oxygen, right? The method to do this, you must draw the table. Okay, so we need to draw the table like this. Now the table will show the steps, and that is very important. Okay, so the first thing on the table is identify the elements present. So the elements present is phosphorus P and oxygen O. Okay, P and O. Step 2, below that in the table, we write mass. Okay, so we got 43.64 grams, and then we got 56.36 grams, like that. After that, we find the AR, the relative atomic mass, not the molecular mass, the atomic mass of phosphorus and oxygen. I believe phosphorus is 31 and oxygen is 16. So now I know the AR, I will find the moles. So mole is equals to, I will prefer to write here mass divided by AR, which is the number of moles. So just take the top number minus the bottom number over here. Top number minus bottom number. So I will have 43.64 divided by 31. It's always good to write the formula, the working over here like this. And then calculate, never leave it in fraction form. So this is 1.408. Not gonna obsess about it too much. And the other one is 56.36 divided by 16, and that is 56.36 divided by 16, and that is 3.523. Okay, so step 5 is one that's a bit confusing. Now, between two of these numbers, I have 1.408 and 3.523. So now I want to find the lowest factor, lowest common factor. What do? I find the smaller number, which is 1.408, and I divide all of the numbers here by it. So what do I mean? This is the smaller number, 1.408. So I'll take 1.408 divided by 1.408 is equals to 1. And the other side, I take 3.523 divided by the smallest number here, divide by 1.408. And then I calculate that, divide by 1.408, and I'll get number 2.5. So now the simplest ratio of atoms is 1 is to 2.5. Okay. However, empirical formula or molecular formula needs to be whole numbers. Okay. At O levels, it needs to be whole numbers. So I have 1 atom of P to 2.5 atoms of O. So how do I make them whole numbers? So the empirical formula is P2O5. Okay, so pause this video first to get a hang of this. Right? So now this table, right? Some of you might be asking, what should I label on my left column? So let me highlight to you the words to write. So the first one, you write elements. After that, mass, AR. I like to write mass divided by AR. I like to write smallest, and I like to write ratio. Okay, so let's look at the next question. An oxide of sulfur contains 40% sulfur and 60% oxygen. So now we don't have mass, we have percentage. Okay, so again, the table, element, mass, AR, mass divided by AR, smallest ratio. Okay, so now the two elements present is S and O. Percentage, just use the percentage. Don't need to worry about converting. So this percentage is 40 and this is 60. Remember AR, not MR. So this is 32, this is 16. Find the most, so mass divided by AR, so always write a working so that we can give you as many marks as possible. Even if you get it wrong, 40 divided by 32 equals to 1.25. And on the other side, I have 60 divided by 16. This is 60 divided by 16 equals to 3.75. Now find the smallest number. The smallest number here is 1.25. So what I take is 1.25 divided by 1.25 equals to 1. The other side, 3.75 divided by 1.25. And the calculator tells me that this is equals to 3. So just nice, the ratio is 1:3. So the empirical formula of this oxide of sulfur is 1 sulfur is to 3 oxygen. So that's the final answer. Okay, so we have more questions over here, anesthetic, and we have another one that is slightly more complicated here. So I would really recommend you to try question 4. Right? If you have followed, there'll be a video that's created to help you. Right? All the best. Good luck.